Bismillahirrahmanirrahim. Nahmaduhu wa nusalli ala Muhammad Rasulullahi Kareem. This problem is related to differential equation of chapter linear equation of second order with variable coefficient, because we seeing here 1 plus x is a variable coefficient and also coefficient of y is x, which is variable. This is differential equation of second order. Solve d2y over dx square minus 1 plus x dy over dx plus xy is equal to x. This is a problem to solve. So first of all, we find the part of a complementary function. So we compare this equation y standard equation of second degree d2y over dx square plus p dy over dx plus qy is equal to r. So we get here coefficient of dy over dx, which is p, equal to here minus 1 plus x. Also the coefficient of y, which we denote q, which is here x, r equal to, which is on the right hand side, x. We know the formula for finding the integral which is part of complementary function by seeing value of p q r. We are seeing here value of p or q, which indicate that if we find p plus q plus r, it is equal to 0, and by this we can say that which is part of complementary function. So we put the value of p and q here. P is value is negative, so we write minus 1 plus x, and also value of q equal to x. On opening this bracket, we get minus 1 minus x and cancel out x1 x and 1. We get value of 1 plus p plus q equal to 0. Therefore we can say that y is equal to e to the power x is part of complementary function. So write the given equation as equation number 1. This is part of our solution. So we start from here in solution. My equation is written here, so you should write in solution starting from this equation number 1, and after it you should write substituting y is equal to uv. Here u is equal to e to the power x. So we put u into v means e to the power x into v, so that dy over dx become, on differentiating this by first and second, first function as a differentiation of second, and second function as a differentiation of x. Differentiation of e to the power x equal to e to the power x, and also we should find the value of d2y over dx square, so that we can put in equation 1 value of y and dy over dx and d2y over dx square. Because y is equal to this, we must put this value and also this and this value. So we have to find d2y over dx square by differentiating dy over dx again with respect to x. First we differentiate this term. We get first function as a differentiation of second, and plus second function as a differentiation of first. Differentiation of e to the power x equal to e to the power x. Also here there are two functions. We apply same formula. First function written as and differentiation of second, which is equal to e to the power x, plus second function write as and differentiation of first dv over dx. On opening these brackets, we get second order differential coefficient is d2v over dx square multiplied by e to the power x, and here these two terms like terms, so we can add up this equation in 2 times e to the power x dv over dx, and only term of v is equal to v e to the power x. So we are able to put these three values of y dy over dx and d2y over dx in equation number 1. We have write here substituting this value and this value in equation 1. So equation 1 becomes on putting the value of d2y over dx, dy over dx and y, we get value of d2y over dx is this. So write this value in equation number 1. We get e to the power x d2v over dx square plus 2 times e to the power x dv over dx plus v e to the power x minus 1 plus x. I write from equation number 1, and now I will put the value of dy over dx, which is equal to written here. So I write it here, e to the power x dv over dx plus v e to the power x. Now next term is xy, so we will write plus x and value of y, which is substituted e to the power x into v, and right hand side equal to x. First of all, we divide whole equation by e to the power x, because e to the power x present in all three terms in here. So we get d2v over dx square plus 2 times dv over dx plus v, and minus 1 plus x. Also this two terms divided by e to the power x, we get dv over dx plus v, and this term also divided by e to the power x, we get xv, and right hand side x divided by e to the power x. Now I want to separate different terms of second order differential coefficient term and first order. Here coefficient is dv over dx equal to 2. Also we get coefficient of dv over dx. When we multiply this value to this, we get minus 1 plus x, which is coefficient of dv over dx in this term. So it is only 2 terms, so we collect here. After that we should collect the coefficient of v. Here there is no written coefficient of v, but we know that it is coefficient of v is here 1, so write 1 here, and v is in here. So on multiplying minus 1 plus x to this term, we get the coefficient of v is 1 plus x. Also here v present, and coefficient of v is x, so write x here, and this is coefficient of v, so we multiply v here. On right hand side we write x, and on we going e to the power x on to numerator, we write e to the power minus x on. After it we write d2v over dx square, and opening this bracket, then 2 minus 1 equal to 1, and the sign of x is convert to plus to minus by this minus sign, so we get dv over dx, and also sign of this bracket terms change from plus to minus, so both the term negative and this x positive, x e to the power minus x without any change on the right hand side. But here see that x cancel out by minus x, and also plus minus cancel out by minus 1. Now we see that the coefficient of v is 0, so simplified equation is d to v over dx square plus 1 minus x dv over dx is equal to x e to the power minus x. For solve this equation, we can write dv over dx as p, so that on differentiating with respect to x whole equation, we get d to v over dx square equal to dp over dx. These two values put in equation number 2, then equation 2 reduced to this. We write d to v over dx square for dp over dx plus 1 minus x. With this value is replaced by p, we get a linear differential equation. Compare this equation with dy over dx plus py is equal to q, so that we can easily find the value of p and q and solution of this equation 3, because we know that the solution of this differential equation is y into integrating factor is equal to q into integrating factor dx plus constant of integration. Integrating in factor, we know that integrating factor for this differential equation is e to the power p integration of p dx. But in our question, value of capital P is equal to 1 minus x, you can compare, and capital Q equal to which is present on the right hand side, x e to the power minus x. So solution of differential equation which is represented by equation 3 is here dependent variable not y, here dependent variable is denoted by small p. So solution of differential equation 3 by this formula is given by p into integrating factor, but I have not find here integrating factor. So first of all find integrating factor, then right solution. So we first find integrating factor, which is equal to according to this formula p dx, but value of p is equal to 1 minus x dx. So integrate 1 and x separately. Integration of 1 is x and integration of x equal to x square by 2. We get integrating factor of this. So we can write solution of differential equation, which is represented by 3, is dependent variable p and multiply it to integrating factor according to formula which I write on the previous page. So you can see that formula, and according to that formula q into integrating factor dx plus constant of integration, which is here c1, because this differential equation is second order differential equation, and on solving we get 2 arbitrary constant, because we have to find general solution of the given equation. So first constant is c1, we first of all we should write the value of integrating factor and q. Integrating factor we have find here e to the power x minus x square by 2, and value of q, which is from equation number 1, which is value of equation right hand side of equation number 1, x e to the power minus x. Also integrating factor we have find x minus x square by 2 dx plus का c1. So we should solve it because these here both factor of e to the power some power which is multiplied, since bases are equal, so write e only one times and write the all power with plus sign. So here it is power of x e is equal to minus x, and here power of e is x minus x square by 2, which will be add according to and as is rule. Here we see that x is cancelled out by minus x, so we get x e to the power minus x square by 2 dx plus c1, and write the value of small v, which is equal to dv over dx. So I write dv over dx, and it is multiplied by e to the power x minus x square by 2. We should integrate this value by letting minus x square by 2 equal to t, and after transposing minus and 2 on the right hand side we get x square equal to minus 2 into t. On differentiating we get 2x dx is equal to minus 2 into dt, cancel out 2, we get x dx is equal to minus dt. So we can write x dx as minus dt. In this equation we get we write write as dv over dx. We write left hand side without any change, x minus x square by 2, right hand side integration of e to the power, we let minus x square by t x square by 2 is equal to t, and x dx which is equal to minus dt plus का c1. Here I write c1 here. Minus is a constant, so we take out minus from this sign of integration, and we get dv over dx into e x minus x square by 2 equal to minus e to the power t dt plus c1. Integration of e की power t is equal to e to the power t plus c1. I write we should write the value of t here, because the work of t is completed work is completed. Now there are two variables x and v, so we separate easily and integrate it. First we divide this factor and get dv over dx as e to the power x square by 2 divided by e to the power x minus x square by 2, also c1 divided by e to the power x minus x square by 2. Also we can write dv equal to minus here base is equal to e, so we write e only one times, and because this term is divided by this, so write x square by 2 power of numerator minus power of denominator x minus x square by 2, plus we can write e to the power e in numerator by changing the sign of its degree. So sign of degree terms change. This positive term changes to negative, and positive term negative term take change to positive, x square by 2, and dx transpose to right hand side. When both variables are separated, we should note that dx and dv are on in the numerator, and terms of x with dx and terms of v, which is not present here, with dv. So we can find the value of on integration. We can find the value of v with integration. On integration we get integration of 1. We can write 1 here with respect to v, and we should integrate these terms. What here we are seeing that on opening this bracket, e to the power equal to x square e to the power minus x square by 2 minus x plus x square by 2 plus c1 e to the power minus x plus x square by 2 dx, which here x square by 2 cancel out minus x square by 2. Integration of 1 with respect to v equal to v, so v, and now we integrate term by term. So on integration of this, here minus is constant, so I take out minus from in sign of integration. We have to integrate only e to the power minus x with respect to x. On integration of this term, by using the linear property of integration, we apply this integration sign this term on this term. So since c1 is constant, so we take out c1 from the sign of integration, and only this term we have to integrate x e to the power x minus x square by 2 with respect to x. We know that integration of e to the power minus x equal to e to the power x, but we have to divide the coefficient of x, which is minus 1. So I divide minus 1 here, plus c1. Here we say that this is impossible to integrate, so we leave it without integration. But when we on integrate both sides, we should write constant of integration c2 here, we should write c2 here, we should write c2 here, integration with respect to x. This minus convert this minus to plus, we get v is equal to e to the power minus x plus c1 e to the power minus integration of e to the power minus x plus x square by 2 dx plus c2. Put this value, and therefore the complete solution is y is equal to when we substitute this value, y on letting this is a complete solution, y is equal to e to the power x into v. So write the value of v here, we get the complete solution of given differential equation e to the power x. Now we should write the value of v in bracket e to the power minus x plus c1 e to the power minus x plus x square by 2. This is minus x, which is integration of e to the power minus x plus x square by 2 dx. Write whole these term in here in bracket without any change, c2. We can you can write you can take you can open this bracket and multiply e to the power x in all three terms. We get y is equal to e to the power x plus minus x plus c1 e to the power x integration e to the power minus x plus x square by 2 dx plus e to the power x also multiplied to the last term c2. So we get c2 e to the power x. We can cancel out minus x plus x, and the power of degree of e is equal to 0. So a is equal to 0 equal to 1. So we can write y is equal to 1 plus c1 e to the power x multiplied to integration e to the power minus x plus x square by 2 dx or plus c2 e to the power x, which is complete solution of given differential equation. Thank you very much indeed for listening me. Wama alaina illal balag.